Hello everyone, welcome back to my channel. So today I am going to talk about MCP servers, Model Context Protocol, and especially I am going to talk about the servers available for Azure, Atlassian, Microsoft Fabric and Azure DevOps platform. क्योंकि यदि मैं अपनी बात करूं तो I am also using a lots of MCP server to do my daily tasks. For example, whenever I need to create a documentation, I leverage this Atlassian MCP server. And for resource creation and resource management in Azure Cloud or for my account, I leverage this Azure MCP server. So in this series, I am going to show you how you can do the setup and how you can leverage those MCP server. So it is super easy to use and it will help you to boost your productivity and you can do your work easily with this servers. For example, whenever I need to manage my work items or I need to update my work items, put out some comment on my work items, I leverage this Azure DevOps server. So we are going to talk about this MCP server in detail. I am going to show you the capabilities for each of this server and how we can leverage this MCP server as well. So if you are new to the channel, please give a like and subscribe to my channel. So moving forward, let's talk about MCP first. So what is MCP? So MCP is an open standard which is developed by Anthropic so that AI system, especially LLMs, can communicate with each other or external data sources or external tools or services. So for example, if you see in this MCP architecture, so we have one host and there are several hosts available, that is Cloud Desktop, Client, GitHub Copilot and Cursor. So there are lots of hosts available which provide this MCP capabilities. Inside this host, we have this MCP client and this MCP client is responsible for communicating with MCP server. Now this MCP client communicates with MCP server via this MCP protocol. Earlier, there is no such protocol available, so every developer, when they need to connect with external data sources, they do their configuration, they need to manage the configuration, they need to check for security as well, that if the connection is secure or not, if it follows the standard protocol or not. So all these things need to be managed by developer, but when this MCP protocol comes, so all that headache remove and simply MCP client can communicate with MCP server via this MCP protocol. So here you can see MCP server A, local data sources A, MCP server V is connecting to local data source B, MCP server C is connecting to web APIs and available in remote services C. Now, if I talk about behind the servers, there are lots of capabilities available which we refers to as tools. So we are going to talk about that as well in detail. And here you can see we have this host. Inside this particular host, we have MCP client available, and this MCP client communicate with this MCP servers and MCP servers via this transport layer. We are going to talk about this transport layer in detail as well. So this is all about MCP, and it is an open standard that is developed by Anthropic. Now moving forward, before and after MCP. So what are the challenges we have before MCP and what are the advantages did we get after MCP? So first of all, there is N cross M data integration problem. N cross M data integration problem means suppose you have three API application and each of this application needs to connect with external data sources. So as I said earlier that for that each developer will connect to this data sources differently. There is not a common protocol that they will use and they need to manage the security as well, and they need to also look out for performance as well, that how LLMs can interact with their external sources. Because if I am building a chatbot for customer support and I need to connect with this external sources, and if the connection or the configuration with the external sources is not proper, then the performance is also not proper. So that is also one of the problem. And now suppose if the connection is also proper, connection and configuration is done properly, but suppose I am building three API application. Now for first API application I need to connect with five sources, so I have built five pre-built connectors. Now there is another AI application. Now again I need to do the configuration and I need to create a custom connectors and custom integration I need to do. And for example, suppose for coding assistant for developers I need to connect with four sources. So four connectors is there and five connectors for my first chatbot application. So nine connectors will be there. All right. Now let's see in this example. three AI application, and each needs to connect to this four sources. So for each of this AI application, I need to do the configuration and setup for this external sources, which results in 12 custom integration. And for every app tool pair, that's a lot of duplicated effort, testing and maintenance, correct? But after MCP, this M cross N solution reduced to M plus N solution. What we need to do, there are lots of servers already available in the market. So for example, let's say we have the four servers, GitHub, Slack, Salesforce, internal databases already available. And when we are creating this AI application, uh, so there is no need to do the custom integration or custom connection or configuration. We can simply leverage this MCP servers to do the communication or to establish the connection. So for example, for each of these three AI application, if we have four MCP servers available for each of the sources, so only seven components are required. So the multiplication reduced to addition. That is from 12 custom integration. In this example, 12 custom integration, it is reduced to seven components only. And even if there are other AI application that also needs to leverage this external data sources, so then also we don't need to do anything. We can just simply connect to those AI application using this MCP server because it follows the common standard, it is secure, and no headache is required, no maintenance, no duplicated effort is required. So this is one of the problems solved after MCP comes into the market. So in this example also, you can see before MCP, here is a LLM. Suppose I have built an application that leverages this LLMs, and this LLM need to communicate with this external sources, Google Drive, GitHub, and to establish the connection, as a developer I need to do the configuration, I need to make sure that it is secure, I need to make sure about the performance as well. So all this headache are removed via this model context protocol. Now you can see we can connect to this external servers using model context protocols, and LLMs can communicate with this external sources easily via this protocol. Okay, I hope you get the idea of what are the advantages that we get after MCP introduction. Correct? Okay, so let's move forward. So let's talk about the core components of MCP. So in MCP, there are majorly four core components. So first is the host application that I also said earlier, that inside the host application we have MCP client enabled. So for example, if I talk about host application, so here you can see this includes Cloud Desktop, AI enhanced IDEs, Cursor, Client, GitHub Copilot, and there are a lot more in the market today. If I talk about the host application, now inside this host application, we have integrated MCP client. Inbuilt MCP client is integrated, which is responsible for communicating with MCP server. So this translate between the host requirements and the MCP clients are built into host applications like the MCP client inside Cloud Desktop. Cloud Desktop is our host, and MCP client is built inside this particular host. Now, MCP server. So, as I told you before, inside these servers, we have context and capabilities that we refer to as tools. And each standalone server typically focuses on a specific integration point. For example, as I also told earlier, that for GitHub, or for Atlassian, or for Azure DevOps, we have different servers available for each of these tools. Now, transport layer. So in the architecture, we have seen this MCP client communicates to MCP server using this transport layer. Now there are two modes, STDIO mode and STTP plus SSE, server sent event modes. So if I talk about STDIO mode, so it is usually for local integration where the server runs in the same environment as the client. If I talk about HTTP plus SSE mode, so it is remote connections with HTTP for client request and for server responses. And all this communication in MCP uses this JSON RPC 2.0 protocol. You can go to Wikipedia and read about this protocol in detail. because so it is the underlying message standard that MCP uses, which provides a standardized structure for request, response, and notification. So these are the MCP core components. A host application, inside host application, MCP client is inbuilt, and this MCP client communicates with MCP server. Inside each server, there are lots of capabilities and tools available that LLMs uses to do the task, and the communication between MCP client and MCP server is happen via transport layer, and there are two modes in transport layer: STTIO mode, which is local mode, and STTP plus SSE mode, which can be referred as remote mode. Okay, so this is all about MCP core components. Now let me show you the different MCP servers available in different areas which are ready to use. Before that, let's talk about how actually MCP works. So when a user interacts with a host application, so suppose I am a user and I am leveraging GitHub Copilot, and I am interacting with MCP server using this GitHub Copilot. Now GitHub Copilot is my host application. Inside that GitHub Copilot, I have MCP client already pre-built. Now, several process occurs behind the scenes. Okay, user asks cloud desktop or so that's it. Now, first of all, protocol handshake, initial connection. So when an MCP host like cloud desktop, so for example, I use GitHub Copilot as a host, and inside that host, inbuilt MCP client connect to the configured MCP server on your device or available report server. If there are local MCP server, it will communicate to that, or if there are remote server, it will communicate to that. So that initial connection happens. Then there is a capability discovery part. So the client asks is server, what capabilities do you offer? Suppose I am leveraging Azure DevOps servers, and my client will ask that particular server that what are the tools you are offering to perform the jobs. So, for example, Azure DevOps servers are offering to manage your work items, to create your work items, etc., etc. So, this comes under the capability discovery. Then there is a registration. The client registered these capabilities. So now my MCP client knows these capabilities, making them available for the AI to use during our conversation. Now, whenever we write some prompt and send it to our LLMs. Now LLMs will check that this capabilities comes into which particular servers, and what are the suitable capabilities that LLM can use to do this particular task that is mentioned in the prompt. So this is what we called as registration, so that LLM can know which capabilities to use to do the task. So this is how MCP works. Now let's see some of the useful MCP servers available in the market that are ready to use, which we can plug and start using. So first of all, let me talk you about some MCP servers in cloud and infrastructure. So Azure and Azure DevOps. So these two servers, I am also using these two servers to do my task. And then there is a Terraform as well. Then there is Convex for backend databases and function for real-time data operation. So here you can see with Azure, we can manage Azure resources, query databases, and access Azure services. So this thing I do usually because that saves me a lot of time. And for data and analytics as well, so you can see we have this Neon, DuckDB, Firecrawl, Prisma Postgres, MongoDB databases, Microsoft Clarity provided by Microsoft for data including heat map, session recording, and user behavior. And we are going to see most of these servers in details, and we are going to see how those servers works, and how LLMs select appropriate tools and perform the tasks. And if I talk about the productivity as well, so here you can see we have Notion, Linear, Sequential Thinking, Memory, Zapier, Monday.com, Atlassian, which I use a lot to manage my Confluence account to do the documentation and all. And then there is MCP servers for development as well. So for Hugging Face, Playwright, GitHub, this is also one of the useful MCP servers that most of you also use to maintain your GitHub repository issues and pull requests. And then there is a Microsoft Docs as well. So these are the several tools available for development. Now let me talk about Azure MCP server and with GitHub Copilot integration. So Before practical, let me explain you that what we are going to do. So first of all, we are going to test the Azure MCP server, and the host application is our GitHub Copilot. And I'm going to show you how you can enable GitHub Copilot, and I'm going to use Visual Studio Code to leverage this GitHub Copilot. Okay. Now, built-in MCP client in IDE. IDE, that means host. GitHub Copilot is already available in Visual Studio Code, and inside that GitHub Copilot we have MCP client available. Then configuration via MCP.json file I'm going to show you in a while. Then we have integrated with development workflow. Then automatic tool discovery, one-click server installation, native IDE integration. So I am going to show you all this. Okay. Now, first of all, let's understand the working. Then I will show you the practical so that you will understand it better. So here you can see I am a user. I have started GitHub Copilot in the agent mode. There are two mode that you will see. One is ask and other one is agent mode. So always use agent mode to leverage MCP server. Now GitHub Copilot, this is my host application which is in agent mode. Correct? Now GitHub Copilot AI models. Now when in all the host application, we can also specify that what models are we going to use. For example, GPT 3.5 Turbo, GPT 4.0, or other models that are available in the market as well. So there are several models that are available. GitHub Copilot, I am going to show you that as well. Then we have this MCP server. So for example, consider this as your MCP server, and then we have our Microsoft Azure, which is in the last. So GitHub Copilot started in agent mode. We have MCP server installed. So GitHub Copilot agent mode. So MCP client that is inbuilt inside this GitHub Copilot will initialize and discover tools. Okay, and this MCP server will respond it back to available capabilities like list workspaces, get Azure resources, query subscription, manage VMs. Okay, so that's how it will respond to the LLMs. So this is what we called as registration. Now, how it will test the connection. So GitHub Copilot started in agent mode and test connection. So if the connection is not successful, it will throw an error. Otherwise, what it will do, it will tell you to sign in to your Microsoft Azure account. Once you do the sign in to your Microsoft Azure account, a .azure file is created in your local directory which it leverages, and then the connection was established. Once the connection was established, we have this Azure tools available ready to use. Now comes the user query processing phase. So here you can see I have typed a prompt, show me my Azure workspaces. So it so I have typed the prompt to GitHub Copilot. Now AI agent uses LLMs and analyze. First of all, AI agent will analyze query, search for available MCP tools. It will select the appropriate tool to do the list workspace. Okay, and then it will execute the Azure operation tools call list workspaces, and then it will go to the MCP server. Now this MCP server, as we have already established the connection, it will go to the query workspaces, get subscription workspace. It will run this Azure CLI command, and this Microsoft Azure server or Microsoft Azure will return this workspace data production workspaces list of workspaces, and then the formatted then MCP server uh, respond the formatted result, generate natural language response, and send the conversational response back to the user. So here are your Azure workspaces, production workspaces, development workspaces, testing workspaces. So that's how the Azure MCP server works. Okay, now in the next video, I am going to show you how you can do the setup, and then we are going to test this Azure MCP server. So that's it for this video. Thank you for watching, and please wait for another video where I'm going to show you how you can do the setup, and then we are going to see the tools available for Azure MCP server. So